Hello friends, welcome to the channel. So today's topic is LU decomposition of a matrix, the one more direct method for the solution of a linear system. So what is LU decomposition method? This is another method to solve a set of simultaneous linear equations. Yes, and this method also gives the inverse of a non-singular matrix. Like in last lecture we have seen how to calculate the inverse of a matrix using Gauss-Jordan method. Now here also we can get with the help of LU decomposition. So what are we doing here? Here we are taking the coefficient matrix A of the system and we are going for the decomposed or factorized method. Okay, and that is in terms of the product of a lower triangular matrix denoted as L and an upper triangular matrix denoted as U. That's why it is named as LU, lower triangular and upper triangular decomposition method. Okay, so that coefficient matrix will be converted into a product of two matrices. First is for lower triangular and second is for upper triangular. That is the procedure for this method. And if here whatever we are taking the lower triangular matrix, that is representing a unit matrix, then that method, that particular procedure is known as what? Tool-Tis method. Okay, similarly if whatever we are taking the upper triangular matrix, if that is representing a unit matrix, then that particular solution is known as the Kraut's method. Okay, so the solution, there is a difference in L and U formation. Okay, according to that the method name is changed. So here in this video we are going with the first solution. We are going to take the L as a unit lower triangular matrix. Okay, this method is also known as what? LU factorization or the triangularization method. This is the another name of this LU decomposition method. Okay, so these are the steps for solution, that whenever we are going to for the solution, what should be the steps. So first of all we have to consider the L and U matrix, and here as I told we are going to take the unit lower triangular matrix. So this should be the formation for that matrix. This is representing a lower triangular and here the diagonal elements are unit. Okay, so this is what? Unit lower triangular matrix, and U represents what? The upper triangular matrix. This is my upper triangular matrix. Okay, now this is my first step. Now what is my second step? In the second step, take the given equation, whatever the system is given, into this format. If it is given like in this format already, then there is no need for the second step. If it is not given, then we have to convert the given equations into this matrix format. Okay, after that the third point says that consider A equals to LU, that is the actual LU decomposition formation, where if we are taking A equals to LU, then putting that value here, so we can write that LUX equals to B, just putting the A, just replacing this A with LU matrix. Okay, where we have to find the value of L and U. How we will do that, just we will see after this with the help of a numerical problem. Okay, how to find the value of L and U. And after that, when we will get the value of L and U, okay, then go for the fourth step, that is suppose Ly is an equation in matrix format and that is equals to B. What is my B? That is given in the question. Okay, so here what is my Y? Y is U times X. What we are going to do? We are taking this two product of the matrix as Y. So simply the Ly will become equals to B, that has been written here. Okay, and what is Y? That we have taken as Ux. Okay, that is a column matrix. So here we have to find the value of Y. And after that, in fifth step, when we will get the value of LU, with that we will get the value of Y. And after that, when we get the value of Y, by using this equation, we can get the value of X, what is our point of interest. Okay, so here in this video we will get how to find the value of X, that is the variables, that may be XYZ, that may be X1, X2, X3, like that. And in next video we will see how to calculate the inverse of any matrix using this LU decomposition method. Okay, so let's check what should be the procedure here. This is specified as the procedure to calculate the value of L and U, because this is the time consuming procedure. So we are having a separate look on this. Okay, so how to calculate the L and U value? As we have taken the coefficient matrix A as the product of L and U, and what is my L? That is the unit lower triangular matrix, and what is U? That is the upper triangular matrix. Okay, that product of that is the coefficient matrix, whatever is given in the question. Okay, so first of all we have to take the product of these two matrix. So when go for product, what will be the product procedure? First row multiplied by first column, so that term is my first element, then first row multiplied by second column, that is my second element. Okay, like that we have to go for the matrix product, and that is equals to what? My coefficient method. Okay, and now by comparing each element we can get the value of the lower and upper triangular elements. Okay, so what is that? So what is the value of U11? That is A11. Okay, similarly by comparison we can get what is U12, that is equals to A12. Okay, what is U13? That is equals to A13, right? So we got three elements of the upper triangular matrix. After that we can get the value of this. Actually this is the procedure of this L and U calculation, that first we have to get the value of first row, after that calculate the value of the first column. Okay, and after that the remaining elements, right? So we got this first row elements, so we will get the first column elements. So what is L21 into U11? That is equals to A21, right? So this is that comparing, and after that L31 equals to what? A31, yes, this. And similarly we can compare each and every element of this matrix, so we will get these as the required equations. And now by substituting the values here in these equations we can get all the elements of the lower and upper triangular matrix. Okay, so these are the procedure for getting that value, right? So by this you can get all the values of the lower triangular and all the values of the upper triangular matrix. So let's have a look on the solution, that how to solve a question using the LU decomposition. So this is my problem. You have to solve the equation. The equation is given in this format. The variables are x, y and z. Okay, we have to find the value of x, y and z using LU decomposition method, right? So what is my first step? First step, these are the given coefficient matrix. Okay, so first step says that take the lower triangular and upper triangular matrix, and the product of these two matrix is equal to the coefficient matrix. Okay, so here we have taken this. Now we have to get the value of L and U, each elements of L and U. So this is the result of the product of that two matrix. Okay, so by comparing the each element of this matrix I got these values of the first row. Now what is my L21, U11? That is equals to 1. See, okay. So here by just substituting the value of A11 I got the value of L21. Similarly we can get the value of L31, that is like this. Okay, now we'll go for the solution of this element. Okay, so here you can see we got the value of L21, we got the value of U12. Now we can get the value of U22. Okay, how? By comparing this with this element, right? So we have taken this equation and we are calculating for U22. So this is the value for U22. Okay, similarly we can go for the remaining solution and we can get the value of U23, L32 and U33 by simple comparison method. Okay, so after getting these all values of lower and upper triangular matrix, we can have this as the solution. This represents the matrix L, lower triangular, matrix U, that is upper triangular. Okay, so this is the solution for now. Now what we will do, we have to get the value of x, y and z. Okay, so the next step says that we have to convert the given matrix into this format, the given equation to this format. Okay, what is that? The LUX equals to B. This is nothing but what? AX equals to B. Okay, where A is what? The product of L and U. And now what I am going to do, I am taking the another equation formation. What is that? LY equals to B, where Y is nothing but what? UX. Okay, this UX product has been taken by y. So this is the solution Ly equals to b, where we have the value of lower triangular matrix. The y matrix is a simple column matrix and b is the matrix given in the question. Okay, so with the help of this equation we can get value of this variable, right? And after that what we will do, we have taken ux equals to y, okay, where we have the upper triangular matrix values, x is what? The given variables, and we will calculate from this equation. So after getting this we can get the value of x, y, z. So this is the simple solution. So for getting the value I, this is the solution that we can go by row equation comparison. Okay, so row says that y1 is equals to 9. Okay, y1 is 9 because only one element is there. Okay, the remaining all is 0. Similarly, the second equation formation can be taken as y1 by 2 plus y2 equals to what? 6. So from here, because we have the value of y as 9, so we can get the value of y2. Similarly, with the help of this third equation, we can get the value of y3, that came as 5. Okay, so we got the value of y matrix y2 y1 y2 y3 as 9, 3 by 2 and 5. So by replacing this value into this equation, now we are going to solve the values of x, y and z. Okay, so this is the solution for that, where again we are going for the row equation solution. So first, second and third. Okay, here we will use the back substitution method. So 18z is what? Equals to 5. 18z is equals to 5. So what is z? That is equals to 5 by 18 simply. So that is the value of 5 z. Okay, now from the second equation we can write this equation where we have the value of z. So this will give the value of y. Now we have the value of y and z. We can put that value into this equation and we can get the value of x. So this is the solution. Okay, so here we got the value of x, y and z. So this is the complete procedure of this LU decomposition method for finding the solution of an equation. Okay, this method can be applied to get the n-dimensional solution of a matrix, right? Thanks for watching. If you have any kind of queries, please put your queries in the comment box. Thank you all.